Okay, 15. Which histogram depicts a higher standard deviation? Justify your answer. Remember, standard deviation measures spread from the mean. So you really have to kind of identify the mean. And for both of these, the mean, since they're both fairly symmetric, the mean is going to be roughly in the middle. And then ask yourself, which one looks like it's more spread out from the mean? Okay, even though this one looks like it's more of a peak in the middle. This one, the data is spread out all the way. You've got a lot of data from 30, 35, 65, 70, 75. This one, the data stops at 60, and this one stops at 40. So the data in A goes from 40 to 60 and stops. So this is where the data is in A. It's only that spread out that much about here. See, the scale is really deceiving, so you really have to look at the scale to check it out. So certainly A has a smaller standard deviation. B has a larger standard deviation. So larger, S, smaller standard deviation. Does that make sense? This guy, we're matching the mean and median and standard deviation with their graphs. Let's see, I'll make it a little bit smaller here, see if we can do this. And yeah, I'm not going to do this anymore. We get the answers, I don't think. Although maybe it's helpful. You guys will have to tell me that in class if you're using these. So we've got mean and median are the same on all of these. Okay. And I know you're going, but these aren't all symmetric. And you're right. The mean and median can still be the same if they're not symmetric. Because this may be kind of skewed this way, for instance, but these outliers are balancing it out. And that's the same thing here. This skew this way and this little bit of skew that way is kind of evening it out, and that's true on all of them. So we got the mean and median the same on all of them. Okay. So we got to kind of look at the standard deviation and see what we're looking at and kind of go from there. So the question is, which ones are really spread out? This is really spread about the mean. This one is not. So which one is the most tight grouped together data of them all? So let's kind of look at this and see where we're at. I'm looking at the numbers. This goes from 23 to 120. This one looks like it's really spread out, just big time here. And the center looks like it's going to be somewhere in this range in here a little bit. That one looks like it's going to be this guy here. So 4 is the biggest spread. The smallest one is 48 to 56 overall. We can remember the range is still a good measure to look at for spread if there's no outliers. To give us a good idea. That's going to be a small standard deviation. It's grouped around the means kind of in the middle here somewhere. Mean median of 53, small standard deviation. This looks like it's good for 1. What about these two? These are going to be the toughest because their standard deviations are the same. What about the mean 60? This one there's no way that this mean is 60. The mean's going to have to be 60 on this one. So we're using all of them here. So 60 this is going to be 2, and then this would be 1, 2, this would be 3. Does that make sense how you're just kind of working your way through? You can't really just look at it and go, oh, standard deviation is this. You're just kind of comparing you're comparing the spreads with each other on this, okay? All right, so that is it on that guy. All right, make my clock go away there. 25. Which car would you buy? Suppose that you are in the market, purchase a car, gas price on the rise. You have to narrow it down to 2 choices, and you're going to let gas mileage be the deciding factor. Okay, you conduct a little experiment. You put 10 gallons in each and drive it on a closed track until it runs out of gas. You conduct the experiment 15 times. You record the number of miles driven. Describe each data set. Determine the shape, center, and spread. Okay. What car would you buy and why? Okay. Great review question. Which, after looking at your quizzes, is a good thing to do. All right. So let's look at car 1 and car 2, and we're going to graph each of these. Oops. And I'm going to go ahead and put the data in. Oops. Turn this thing on. In L1, we will put car 1, and L2 will put car 2. Okay, so let you see this start here. And then in L2, we're going to start with 277, and I'll put the data in here. You have to watch that. Okay, here's my lists in. We're going to make a histogram for each of them, and then compare this data. So we got, I want to make sure I remember that. All right, stat plot. Let's do the first one, histogram. Let's see, it looks like the data goes from a low of 178, so I'm going to go from 170 up to a high of 250, say. Okay, sorry for that pause there. So the min's 170, the max is 250. So if we go by, say, tens, and then 0 to 10, say, let's see what that looks like. Okay, that's our car 1. Let's actually look at this. Let's actually do a quick sketch. This is the toughest part, and I probably should have done this on a separate one. So we went from 170 to 250, 200, and if I go to trace, we go 1, 1, blank, blank. And then it's 3, 5, 3, 1. Okay, so this is miles and counts. And then we'll look at car 2. And we got to do that on exactly the same scale if we're going to compare them. And go 170 and so forth, miles. And try not to keep this video shorter if we can here. So let's look at stat plot. And now I'm going to go here. Only now I'm going to count or plot L2. See that? I'm leaving the window the same. Graph. Oh, well, let's look at that. Because L2 goes all the way up to 326. So now I do need to change my window up to, say, 350. So I've got a lot of gaps in there, don't I? Or a lot of more space. So let's trace this out and see what it looks like. So I got one from 180 to 190. That was that guy. Let's get to 90. So I go up to 3. This is a little bit more erratic, isn't it? So this is going to keep on going out here. So this is 240. Yeah, every time I touch the screen, it minimizes the calculator. That's what's. And I've got 250 is 211. this outlier way out here at, so 1, 2. Wow. So I've got 1, 2, 3, 4, and then there's 2. And that's from 320 to 330. Okay, so here we go. Describe each data set, determine shape, center, spread. What would you buy? So then stat calc L1. Oops. Calculate. So for L1, now since I have outliers, I have to use the median for the center. So the median here is 223. Center spread. Now the spread, we haven't learned about spread yet. We're going to actually be doing that in class next. So it's going to be from 170 up to, we said this was 250. So there we go on that. This is, we have outliers and everything, so we're going to look at that and do the same thing on that one. We're going to do stat calc. And then I'm going to do L2. And look at the median on that guy. Because again, I don't want to use the median or the mean because of these outliers over here. And do, the median is 230. Okay, so not, the median is not significantly better, even though I got these two over here. And the spread is going to go from 180 up to 330. So, okay, so if we want to describe the data set, okay, car 1. Car 1 drove from 170 miles to 250 with center 223, and I would identify that as a median. So there's and 2 low outliers. Okay, you could, I don't, there's really not a shape to say this. If these are low outliers, I mean, you really can't say, that's not enough data to really call it a shape. I don't know that I'd say that. With 2 outliers, there is a cluster around 210, 220, 230, 220 to 230. Oops. I'd probably leave it about like that. The spread is from 170 to 250. Okay, I hit all of them. Shape, roughly a cluster here, outliers, center, and spread. Here, car 2 drove from, oh, I repeated the spread twice. Drove from 180 to 330 miles and was or had values spread out throughout. Oops, if I spelled it right. Throughout, throughout. There are two high outliers. I would consider those definitely outliers. They're significantly far away. The center is 230. So we got shape, spread out, outliers, center, spread. Okay, so that pretty much covers loosely for each of these, but does it answer the question? Which car would you buy and why? Well, this one has, the top one has consistently more grouped around 230. Here's 230 right here. This one has, well, some below, but it's got more of them above with the chance of getting some higher ones. So if you want the chance of getting higher ones and some higher, but then you got a chance of getting some lower, then you go with the lower one. So it really ends up being kind of a judgment call on your side being the buyer. So if you're more consistent and say I want to consistently get around the same miles, then you're going to go with car 1. If you're like, nope, this is going to bounce me up some good ones sometimes and maybe not the other, then I'll go with car 2. All right, there you have that.